When you are not sure, right? Mean unsure. When you are unsure, how do you guesstimate something is going to be happening, or something is going to happen, or something is already happened, right? There is a probability, likely to be, those kind of buzzwords you might have hearing. A recent past, you can see probability is widely used in statistics as a tool, and machine learning, artificial intelligence in the field of computer science programming, isn't it? So we have studied probability, started from the lower grade, like an 8th grade, ninth grade, 10th grade, and then all higher grades, till in engineering service and the research and development. Hello everyone, welcome to IGBits. We train, you learn. We will started exploring basic concepts to expertise level in probability. Probability is one of the core subject in mathematics field. Let's get started. Before getting to a understanding of a concept of probability, let's look at a few real-time applications where we use probability. So I'm sure I think we are all one way or other working with the gadgets, right? Like a gaming. When we are playing with a computer, we are always try to see like how I can win over the computer, right? But the computer can also think when it is playing with you, you try to always win over us. So the question here is how the software is really playing, you know, intellectually to win the game over us. So understanding a chance of winning is a core technique with which a software programmings are built for the games. That is where probability is widely used. And also weather forecasting. For instance, a use case like predicting the likelihood of rain is one of the use cases, but there are many more where we are using a probability as an application in weather forecasting area. In finance, assessing a risk in investment where we are using probability. In recent past, you might have hearing a computer science, philosophy, artificial intelligence, machine learning, risk assessment and management. There is many more motivations if you getting into understanding science and technology and in various domains, how a probability is going to play a vital role in solving a simple problem to a complex problems. That's why it's essence for us to understand the concept of the probability. It always gives some kind of curiosity to explore more in detail, like a deep dive of how probability helping us to solve the problems. We might not really think about like so many applications, but eventually you will get familiarized when we started learning a concept and then going the beyond the current stage. So in education curriculums, the probability topic starts from 8th grade, ninth grade, 10th grade, and all other upper classes till engineering and the research areas. Let's look at a concepts from basics. I would like to take a few seconds to let you know that we are now on YouTube channel. Please do visit us at IGBits. We are continuously uploading our sessions to make sure available for you all to access at your own time. One request that I would like to convey through this channel, please do help extend your support to your friend circle to share our knowledge base to help them to build their knowledge. Thank you for so far whatever the help that you've been doing. Continuously do same helping hand to us to build a knowledge base to help everyone. Thank you all. Probability is a commonly used word in day-to-day conversations. For instance, I'm going to read the few sentences. You can sense how probability is trying to convey the information for us. Probably it may rain today. Does it make sense to you? We are not sure whether rain is going to happen, rain is going to come, rain is going to occur. But what we are saying is probably it may rain today. So we are not sure. So unsure activity, uncertainty is what you are trying to address by doing that statement. So few more. She may possibly join in movies. Right. So you are not sure, but you are saying like some certainty, some uncertainty is exist when you use possibly. Right. Indian cricket has good chance of winning World Cup. So we are not stating that affirmative word like it is going to win. What we are saying is like a chance of winning World Cup. There is like some uncertainty, some certainty, sure and unsure kind of things is conveying in the statement. She is probably right, but you are saying so most likely I know what she is telling is right, but you are not saying that she is right, isn't it? So this is how you can infer probability. I may probably get a good rank in a competition exam. Recently, I took an exam. I'm waiting for the results. What I'm saying now is I may probably get a good rank. Likely to be. Yeah. So the word probably, possibly, likely, what it conveys is like some sense of event that is not certain. Another word, uncertainty of occurrence of an event. So we are saying some certainty or some uncertainty, whatsoever. That is what a meaning of probably when you're using a keyword called probably. So in theory of probability, in a nutshell, what we are saying is we assign a numerical value to a degree of uncertainty. We are assigning a numerical value to a degree of uncertainty in probability. While studying probability to build the concepts, three cases that everyone can think through. And then since I learned, I always you know it reminds me those cases. First one, tossing a coin. So when we toss the coin, what we are trying to see is getting head, getting tail. So what is a possibility in getting head or tail, right? This is one thing that we do. Similarly, rolling a dice, throwing a dice. So dice means it's a kind of a cube. We have six faces, and then you number each facet like one, two, three, four, five, six. Now, when we roll the die, what is the number that it comes on the one facet of the cube, right? Where you are observing. So that is again a subject of probability. So one more, drawing a card from pack. So these are the three, the case studies with which we can build the concept of probability. Look at little high level approach to probability means like how you do calculate a numerical value to a degree of uncertainty. So there are two approaches for this. One is experimental approach or imperial approach. The other one is theoretical approach. Experimental approach means you do some activity, perform the experiment. When perform the experiment, record the result. Whatever is happening, record the happening of event, that right, that is an outcome. Result is nothing but outcome, right? Probability of an event is based on what actually happens, is what you are going to record. So in a way, through the experimental approach, you will be able to assign a numerical value to a degree of uncertainty. When we say experimental, there are the two methods in turn. What those are all? Deterministic and random. Deterministic name implies if you obtain almost the same results when experiments are repeated under identical conditions. So means like you are repeatedly doing the same experiment with same identical conditions, then you likely to get same results. Let's say if you are getting same results, then you say your experimental approach of getting probability is deterministic. Whereas other case, I am doing experiments in repeated way using same identical conditions. However, I am not getting same results. In that scenario, that nature of the result that you're getting is known as a random probability. So tossing a coin, rolling dice, drawing card from the pack, these are all a kind of best examples for random probability. When we have a probability, you know, uh, you know, through the experimental approach, then why would you need to study the theoretical approach? Interesting question, right? The one simple answer for that is, if the number of experiments that you supposed to do very large, then it is practically is not possible for you to do the experiments, right? Right. That in that case, we use a theoretical approach based out of the past experience in that particular problem domain to predict what is going to happen as a probability. That's why the probability in a nutshell, all these approaches is going to help you to understand how you will be able to assign a numerical value to a degree of uncertainty. That was the concept of probability at a high level. We all know that we have a coin. Coin has a two sides, right? So if typically this is like Indian, currency, Indian coin. So the coin has a two sides. One is head, one is a tail. Right. Only there is a two possibilities that we are going to see from the coin, isn't it? Do you have any third, scenario? Absolutely no. Good. So now, let's say you are tossing a coin. So what is going to happen? Either you are going to get a head or the tail on top of the coin when we do this experiment, isn't it? So getting head, getting tail. There is a two possibilities that we can think through. So, so these two possibilities is known as an events. So in the event, the outcome, the end result is what we say as a either head or the tail. So getting head from an event is an outcome. Getting tail from an event is also an outcome. Right. So how many events totally we have? Two events. Within the two events, what is the probability for getting head or getting tail? This is 50%. Out of two, one would be head, one would be tail. That is how you look at. So few keywords that that we are going to use frequently. So let's go through them. First one is experiment. A procedure that generates an outcome is nothing but an experiment, right? Like a tossing a coin, right? For getting an outcome, outcome can be head or tail. That's called an experiment. Outcome means a result of an experiment. A possible result of an experiment is known as an outcome. In our case, like head is an outcome, tail is an outcome from our trials. Trials means an experiments. Sample space. Sample space means set of all possible outcomes of an experiment. So when we are doing an experiment, we say that we are getting an outcomes. What are all possible outcomes that I am going to get from an experiment is nothing but my sample space. Okay, we'll look at few more examples, but that's the definition that it says. Event is what? Event means like an event could be a single outcome or combinational outcomes from an experiment is known as an event. A subset of sample space. From the sample space, you are getting like all the events because every event produces the result from the event. The result is what you are going to put it in sample space, and hence a collection of some outcomes of an experiment is called as an event. So experiment, outcome, sample space, event are the keywords that you have to remember. This is going to help us to actually do you know conceptually solving the probability problems easily. So for instance, so you are conducting an experiment. So the experiment is basically for generating an outcomes. Outcome could be getting head is one outcome, getting tail is another outcome, right? This one and this one. So these are the two events, right? This is event one, this is event two. Got it? So experiment is for producing an outcome, you have to do some activity, right? That's called your experiment, like flipping a coin and rolling a dice, picking a card from pack. These kind of things will come. Okay. So now experiment means like the procedure that to generate an outcome. Outcome means the result of an experiment. Sample space means like what? We have two events, right? You can put together two events, getting head and getting tail. This is called your sample space. And then subset of sample space is nothing but a simple event or event. This is called a simple event. Now you see, these are the event, collection of events in your sample space. All possible outcomes you put together and then call them as a sample space. Outcomes means like when you're doing an experiment, it produces an output, right? Those are called outcomes. Getting head, getting tail is nothing but your outcomes. For getting, you do some experiment, right? There's some procedure that you have to perform to getting the result out is called experiments. So the keywords are experiments, outcome, sample space, and event. Now a probability. Probability between these two events, right? Getting head from two events is 1 by 2, right? Your favorable event is like 1, but your total possible events are 2, and hence the probability of getting head is 1 by 2. Similarly, for the tail is also 1 by 2. So in probability, two things for sure that we know. One is the impossible and then one is certainty. The probability for impossible is 0. Probability of certainty is 1. So our values lies between 0 and 1. So any value you will be getting between 0 and 1, including 0 and 1, right? In our coin case, if you see, the coin has two faces, head and tail, right? A likely and not likely, the probability is like f 1 by 2, right? On probability line, the values between 0 and f, right? That what we treated as like a unlikely case. So we start from impossible to most likely not likely limit. So 0 and f are the values. If you can refer it like any value, if you get like in middle of 0 and half, that is called unlikely, which is something like a merely impossible case. The other hand, any value, the probability value which you can get between f 1 by 2 to 1, this is like a likely, because you are moving towards a certainty case. So unlikely and likely are the the keywords that is a takeaway from your probability concepts. And then impossible, probability for impossible is 1, I mean impossible is 0, probability for certainty is 1. Anything that comes in middle for unlikely or likely. So if you look at a number line for this scenario, impossible means like a 0, half means 0.5 to 50%, 1 means for sure 100% is going to happen. You get it? So the probability is the branch of mathematics concerning an events and numerical description of how likely they are to occur. That's the definition of probability. Probability qualifies how likely an event is to occur. Got it? A numerical measure, the numerical value that you are going to assign is ranging from 0 to 1 in the probability. Minimum 0, max 1. These are the two extremes. In the middle, you can get a lot of, a subset of values. 0 means impossible event. That event is never going to happen in that particular scenario. In that case, you say a probability of getting that event is 0. If for sure 100% sure that the event is going to happen, in that case you say the probability is 1, p of a equal to 1. The simple definition for arriving numerical value for degree of uncertainty measure is number of favorable outcomes divided by total number of possible outcomes is nothing but a probability. Probability equal to number of favorable outcomes divided by total number of possible outcomes. Remember, draw inferences about the expected frequency of events is what the probability. You are actually inferring from the experiments and then giving value to a degree of uncertainty is nothing but a probability. Assigning a numerical value to a degree of uncertainty. Let's say you are actually rolling a die, and then what is probability of getting 1 on top of your die, or getting 2, getting 3, getting 4, getting 5, getting 6. So we know that like there are the 6 faces for the cube, for the die, right? So getting 1 possibility out of 6 is what you are trying to say, right? Probability of 1 means getting 1 out of 6. So what is the definition of probability? Number of favorable outcomes. Here favorable outcome is like 1, because getting 1 from your experiment, right, is 1. So the favorable outcome is 1 out of how many possible outcomes? There is a 6 possible outcomes. So if you can denote in numerical representation of a probability, probability of getting 1 would be 1 divided by 6. Probability of 2 would be again 1 event out of 6 events. And then probability of 3 would be again 1 out of 6 events. Probability of 4, 1 out of 6. Probability of 5, 1 out of 6. Probability of 6, 1 out of 6. Right? If you can add them all, like 1 by 6 plus 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 1 by 6. So what happens? So LCM is 6 and the numerator adding 1 plus 1 plus 1 plus 1 plus 1 plus 1, right? So 6 ones. So 6 by 6 equal to 1. So the total probability is 1, isn't? So all individual events, if we can add them together, the max value that what we get is like 1. Theoretically, probability of an event can be defined as if there are n elementary events associated with a random experiment, then m of them are the favorable events. So you are saying in your experiment, n is a total events, and then m be your favorable events. Then if you say that event is A, you can call it as A. Then probability of A by definition is your favorable events by total possible events. P of A is equal to m by n is what you say. So the value, if you look at a probability line, so what you're saying is like certainty is probability of A is 1 if certainty is 1. 0 means like it's like impossible event. Middle you have something, right? So what are the value? The P of A between 0 and 1, correct? So what we can say, minimum 0 and max value n. So your favorable events always between 0 and n, right? Let's say you divided by n all. Then what happens? 0 by n means like 0 less than or equal to m by n is nothing but your PA, probability of event, and then n by n is equal to 1. So if you see, your probability of favorable event occurrence lies between 0 and 1. That's what your probability line also talks about. Probability line, right? This is very important topic. So we are saying the same thing here. Complementary events. What is meant by complementary events? So complementary event is something not likely to happen event, right? Not a favorable event. So if m are the favorable events and then n are the total events, then non-occurrence of events would be n minus m. You agree? So now you are saying you are trying to calculate a probability for non-occurrence events. Probability A bar or AC. Probability of A complement A equal to non-occurrence events is like n minus m by n. You got this one clear? So let me explain one more time. Your total is n, your favorable is m, and then your n minus 1 would be non-favorable, non-occurrence. So if you try to calculate a probability for complement, P of A is equal to m by n. Similarly for this, P of A bar, how much this is? N minus m by n. N minus m is like favorable or non-favorable divided by total number of possible events. So n minus m, so you split it this way, then what it means? N by n is 1 minus m by n. We know m by n means the probability of A. P of A is nothing but your complement. So P bar equal to 1 minus PA, right? So P of A plus P of A bar equal to 1, right? So this is what your conclusion. probability of favorable events plus probability of complementary events యొక్క if you put together as a sum, the sum always remains 1, and hence the original theory remains same, right? The max what you get is like 1, min is 0. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Thank you everyone. Thanks for joining. We shall continue our learning in next class. Stay tuned to next session. See you again.